Hello, this is Alex Krotz, and I'm showing a device that I've made which transmits audio signals via a blue LED. You can see this LED over here. This is the one that transmits, and this is a photodiode which receives the signal and then modulates the voltage applied to the input of a set of speakers, just some computer speakers, and it does so with the use of a voltage divider. You can see of the two resistors, one is 470 ohms, the other is the photodiode or photoresistor, I'm not quite sure. Camera is in focus. Okay, there. Okay, well, regardless, my camera is not okay, there it is. Anyway, so you can see the resistor, and in the middle of the resistor is the junction between the diode and the signal, as well as the other end of the resistor. The voltage in goes in directly into the diode, crosses a resistance there, which is modulated by the light intensity, and then goes through the other resistor, which allows me to make sure that the current is a little bit low so that my input doesn't blow up. The voltage source itself is a constant current setup hooked up to, or rather, a constant voltage power source hooked up to a constant current power source which powers the LED. The constant voltage is applied to the sensor, and the constant current is applied to the LED. I've been trying to get it to work with this, which is a laser diode. However, these photoresistors or photodiodes, I'm not sure which it is, or actually, of course, it's a photoresistor. Anyway, they're not very sensitive to red light, so with the laser it does not work as well. The volume is very low and I have to turn the amplifier up quite a bit. Anyway, I should show it working now. Then, of course, the regulator is all attached to a switch mode power supply, which connects to mains. So if we put on a song, and then it connects to my computer's input, or audio output, and then I have a potentiometer which adjusts the constant voltage supply, and this potentiometer down there allows me to finally adjust the current for use with the laser diode. But for the LED, the current's pretty variable. It's interesting to note that at low currents, like low brightnesses, the volume starts to increase as you increase the current. Then it peaks at some point, and then it begins to decrease, and I believe that's due to clipping of the audio signal first on the negative voltage end and then at the positive voltage end, due to the limitation, due to the turn-on voltage of the diode, as well as the cutoff voltage, where the diode begins, I have to think about it more, but rather where the change in voltage by the audio output of the computer is not sufficient to drop the voltage applied to the diode enough such that you hear the volume. Basically, so that it's not clipping, but the entire audio signal is then out of the range of the LED. That's what I think. If it's wrong, leave a comment. Okay, now I'll put on a song, and here you can see the Fourier transform as well as signal input. That's my voice. Let me turn on the device by It's not turning on. Oh yes, I forgot to turn the power supply on. Let me turn off the lights. So you can't actually really see the brightness modulate much unless I turn it down a lot. You can see it sort of increase and decrease brightness. I think I can fix this because I have an input resistor with a resistance, of about 230 ohms, and that's pretty high. I just used it because I was afraid that some sort of current, or because the voltage input the output of the computer input of the LED connects directly to the legs of the LED. I was afraid that the constant current, should the LED burn out, might be applied directly to the computer's output, and that would be bad. Yeah, so thank you.